2023 aspirants. So coming up with an important session, the ISRO examination is going to be conducted now on 17th of December, say around 2 weeks left for you. Of course, you must have revised a lot, you must have prepared, because the notification came up somewhere in May and students were waiting for the exam date. Very recently, the exam date was announced. Now, for such exams particularly, we can assume that, you have prepared the subjects, especially which are common with GATE or engineering services, because you might have gone through one cycle of the preparation of GATE or engineering services. But there are some areas in these exams, be you talk about ISRO or BEL, etc., where, the questions come up from the areas which are not in GATE. Okay, say, be it microwave engineering, be it material science, be it the today's session like microprocessor, be it satellite communication, be it radar, and all of these play an important role. Okay, we have seen that in the previous years of ISRO, whether you look into the 2020 ISRO paper or even, any of the previous 4 or 5 ISRO papers, if you go and scan that, you will be finding questions on microprocessors, specifically 8085. Okay, so that's why I thought of having a question session, okay, a practice session on the microprocessor. On the microprocessor 8085. The important questions on microprocessor 8085 will be taking up today. So let's get moving ahead. Let's get started. This is a regular introduction that you're aware about. So guys, you can also be connected with me in my Telegram group. The name is mentioned here. Okay, and whatever we discuss today, along with the questions and the detailed solution, I'll share you the PDF. And for other important questions, daily dose, and important updates about my sessions also, you can be connected in this Telegram group so that you're aware about all the activities happening, right? Danaji, so the big update of the hour, the big time update is, yes, very recently you know engineering services 2023 results were announced, and okay, UPSC engineering services 2000 results were announced, and here we have all India rank 1 Vineet Jain, all India rank 9 Varun Kumar, okay, 5 aspirants under rank 10, 29 under rank 50, and 37 students have got rank under 100 and still counting. Okay, still counting, right? So congratulations to all these, and we hope and we pray that you also prepare to an extent that you come up in the results, in the top results next year. Okay, yeah, Altaf, even going for extra subject first revision and PYQ definitely is a good approach. Now let's come to the first question, guys. Here it is. Okay, the content of the accumulator of 8085 microprocessor after the execution of the following instruction will be MVI A, A7, ORA A, and RAL. Okay, so with this, with the today's session also, multiple instruction set of 8085 you will be able to revise, I can say that. Okay. Sure, Remy, I'll take up some sessions on signals as well, don't worry. Chalo guys, let's get moving ahead. Let's get started with this question. The MVI A, 47. What is the role of this instruction, dear? MVI A, 47. MVI A, 47. It is going to, okay, it's a move immediate instruction. It will copy the immediate data A7 into the accumulator. That means the contents of the accumulator, of the register accumulator, will become A7. H is for hexadecimal. Okay, okay. Now ORA, what is ORA? Okay, or logical OR operation. It will OR the contents of the given register, that is A, with the accumulator. By default in this logical operations, one of the operand is implicit, that is accumulator, and the result is stored back in the accumulator. So A or A is stored in A. But now, okay, whether it is now OR, like, logical bit by bit OR hoga, and 0 plus 0 is 0 and 1 plus 1 is also 1. Okay, in the basic OR gate, 0 plus 0 is 0, 1 plus 1 is 1. Okay, so that means X plus X is X, we know. So, okay, the accumulator contains A7 and it is still going to contain A7. Then why this instruction has been used? It is not changing the contents of accumulator. Whenever you OR a variable with itself, it is going to not change. Okay, so why the OR instruction is used? To activate the flags. Arithmetic and logical operations will activate the flags. Okay, and every logical operation, okay, OR and XOR, they reset the carry flag always. Okay, they will reset the carry flag. So important thing that you must know is that is going to reset the carry flag, because that carry flag is going to be used in the instruction that is known as RAL. Okay, what is the instruction RAL? rotate accumulator left through carry. Rotate accumulator left through carry. What does it mean is, okay, let us write down the contents of accumulator. Okay, bit by bit, binary contents of accumulator, that is A7, so 1010. A is 1010, 7 is 0111. That is the contents of accumulator along with the carry flag. This is A along with the carry flag, and by the way, the carry flag has been reset because of the ORA instruction. Okay, now rotate accumulator left through the carry. Through the carry means the carry will be included in the rotate cycle, so you have to take it as a 9-bit number. This is just like a 9-bit number and start rotating. Okay, so what will come here? 1 will come here. Okay, ye left shift ho gaya na, you have to shift left, then 0 1 0, then 0 1 1 1, and this carry was also included, and that comes up here. That comes up here. So what is my answer here? Okay, after the execution of RAL, the contents of accumulator, this is 4 and this is 1110, this is E. My answer is 4E. My answer is option number D. My answer is the option number D. Okay, yes, NGC. My answer is option number D. That is known as the 4E. Clear? That is known as the 4E. My answer is option number D. Okay, now. What's next? What's next? Sometimes students are having the confusion in one of the instructions. So let me take up that instruction first of all. Okay, related with this. Okay, related with this. Now this is RAL. Okay, rather than RAL, if the instruction was RLC. RAL is rotate accumulator left through carry. Okay, and then there is the RLC. Then there is this RLC. What is RLC? RLC is simply known as rotate accumulator left. Although it uses the letter C, there is a confusion amongst the students. Okay, but that is the correct, mnemonics that have been used. RLC, rotate accumulator left. Although C is there, but this is without carry. And the previous one, if I talk about the previous one, RAL, that is rotate accumulator left through carry. So always remember that. Always remember that. So difference in the two instructions. Again, I'll use the same example. What was the content of accumulator? What was the content of accumulator? 1010 0111, 1010 0111, and carry flag. And carry flag was reset. Rotate accumulator left. Okay, that means only rotate the contents of accumulator, not including the carry. Okay, so that means 1010, the 0 will come up here. Okay, 010 0111, and this 1. Okay, so I had 0 1. Once again, sorry. So 0 1 0, then 0 111, and then this MSB goes to the LSB. This is 1. This is copied here. Okay. Also at the same time, this MSB goes to the carry also. The carry flag is affected, but not included in the rotate cycle. Okay, not included in the rotate cycle. So what is the answer now? 0100, that is 4. 1111, that is F. The answer will be 4F in that case. Okay, our original answer is 4E, but if it was RLC, then the answer will be 4F. Then the answer will be 4F. Okay, next question, dear. Okay, let us move ahead to the next question then. Okay, here it is. Chalo. Yeah, this question is now going to use RLC, and I've already explained you what RLC is. 8085 assembly language program is given below. Assume that the carry flag is initially unset. Unset means like reset. It is specified that carry flag is initially unset. The contents of the accumulator after the execution of the program. So there are certain steps now. Okay, let's start this again, guys. MVI A, 07. Okay, MVI A, 07. Okay, so what it is going to do, it will load the data 07 into the accumulator, and then RLC. And then RLC. Okay, so see, what is 07? 0, 0, 0, 0, and 7 is 0, 111. Okay, 0, 111. Okay, now do the RLC. Okay, now do the RLC. Okay, now do the RLC. What is going to happen? What is going to happen? Okay, what is going to happen? Now, you know, all of them are RLC or RRC. Rotate accumulator left or right. Okay, without carry. So just rotate left. Okay, so that's going to bring the accumulator to the stage 0, 0, 0, 0. Okay, इसको पहले left shift कर दिया 0 0 0 0 1 1 1 and then this will go here. Okay, so I'll write down 0 here. Okay, so what is this? Okay, this is known as 0E. This is known as 0 and this is 1 1 1 0, that is E, converting to hexa. Move B comma A. Okay, move between register. This is the source, this is the destination. Okay, from A to the B. So B will get the contents of the register A, that is already OE. That is already OE. Now again RLC. RLC, see, RLC is always applied to the accumulator only. So whatever was the previous content of accumulator, that is OE again. Again rotate left. Okay, तो पहले इसको ले लेंगे 0 0 0 1 1 1 0 0 0 0 1 1 1 0 and MSB will come to the LSB, that is 0 comes here. Okay, again RLC. Again RLC. Okay, so 0 0 1 1 1 0 0 and MSB goes here. Okay, that is known as 0. Okay, now add B. Acha, so addition in hexa karoge to zyada easy hoga. So this is 0 0 1 1, that is 3 and 1 0 0 0 is add. Now add B. What is add B? Add the contents of register B with that of accumulator and result is stored back in accumulator. Okay, okay, so that means what is B? 38 and what is this? A is OE, B is 38, दोनों को add कर देंगे. So E plus 8. Okay, just keep doing the calculation. E plus 8, so that is equal to F. Then 1 0, 1 1, 1 2, 1 3, 1 4, 1 5, 1 6. We stop at 1 6. Hexadecimal में count कर रहा हूँ and this is 1. 1 plus 3 is 4. This is 4 6. Okay, now RRC. One last step. Okay, now that is the RRC. Okay, so what is the contents of accumulator after this? 4 6 0 1 0 0 0 1 1 0. And now once you do the RRC, rotate right. Rotate right. Just rotate right without the carry. Just rotate right without the carry. Okay, so without the carry. Okay, this time right rotate hoga. So LSB will come to the MSB. Okay, LSB will come to MSB and then 0 1 0 0 0 1 1. This one. This one. This is 2. This is 3. Correct answer at the end is 2 3. Option number C. Correct answer at the end is 2 3. That is the option number C. 2 3. 2 3. Option number C. Okay. Next question. Okay. So in 8085 microprocessor, contents of the accumulator after the following instruction are executed will become how much? Okay, will become how much? Look into this. First of all, XOR A. Okay, XOR A. Okay, again, XOR. XOR, it's logical XOR. Okay, XOR with the contents of accumulator. Which register? That is also accumulator. So A XOR A. Okay, and the result is stored back in the accumulator. Acha. Now, dear, any bit you take, X XOR X, that is always 0, na? Because XOR produces high output for different bits. Okay, here, okay, even if you go bit by bit, but all the bits are same, na? Because both the contents are accumulator, and that is why, okay, the entire answer will be 0 0. Okay, the accumulator will contain 0 0. It is just a way to clear the contents of accumulator. It is just a way to clear the contents of accumulator. Okay, now MVI B comma F naught. Okay, MVI move immediate. The given immediate data move to the register B. So B now contains F0. Okay, sub B. Okay, subtract. Subtract from what? By default, guys, arithmetic or logical instructions, one of the operand is implicit, that is accumulator. Subtract B from the contents of accumulator. Result is stored back in the accumulator. Okay. So what is going to be the accumulator contents now? Accumulator actually 0 0 minus B, and that is minus F0. That is minus F0. Now, rather than subtraction, what you can do is, you can subtract as well, no problem. Okay, or what you can do is, okay, rather than subtraction, you can add with the 16's complement. Okay, you can add with the 16 complement. This is also equal to 0 0 plus 16's complement. Anything you want to do. Okay, what is going to be 16's complement of F naught? By किसी भी number का 16's complement. First calculate the 15's complement by subtracting from F. Okay, F minus 0, F minus F is 0. Okay, and then add 1 to the rightmost digit. So F plus 1 is 0. F plus 1 is 1 0. Na? So sum 0 carry 1 and 1 plus 0 is 1. Okay, that is the 16's complement. Okay, so that is 1 0 and the final answer is 1 0. Okay. After the execution, contents of accumulator. These are conceptual and instruction knowledge questions. Okay. Chalo. let's move ahead to the next question then. Okay, yeah, here do we have the next. An 8085 microprocessor has executed the following instructions. Okay, from which address will the next instruction be executed? What do you know about the next instruction execution? From which address is the next instruction executed? Okay, from which address is the next instruction executed? The next instruction is executed, okay, from the address which is stored in, okay, program counter. Okay, the address of the next instruction is stored in the program counter, PC. That is what is known as the program counter. That is what is known as the program counter. ठीक है, चलो. That is what is known as the program counter. ठीक है, done है. चलो. Now let's solve this program here. Okay, so there are some addresses onto which instructions are written, and what is the instruction? LXI, load register pair immediate. Okay, commonly when X comes in, that is a register pair actually. Okay, so load register pair immediate. Okay, this is what load register pair immediate, LXI. Okay, so it will load the register pair H for HL, okay, with the data 8A79. So HL will get the data 8A79. That means H 8A and L will contain 79 respectively. Move A comma L. Okay, move A comma L. Move between register. So it will copy the contents of L to that of the accumulator. A will be equal to L, and L is how much? 79. Everything going in hexa. Okay, add H. Add H means what? Add the contents register H with by default accumulator. Okay, result is stored in accumulator. A is equal to A plus H will be done. Okay, so A is A plus H. What will be the answer? Okay, what is A now? 79. And H यहाँ से निकालेंगे. HL में से H is 8A. Okay, how much is this answer? 8A plus 79. Okay, so A plus 9. B, C, D, E, F. 1, 0. Okay, then 1, 1, 1, 2, 1, 3. It's going to be 1, 3. So 3 here and 1 here. Okay, 8 plus 7, F plus 1, 1, 0. So 0 and 1 will be again a carry. Now DAA. What is this DAA? So I told you, multiple instructions you will revise through today's session. Okay, DAA, decimal adjust accumulator. Okay, now how is the result? How is this adjusted? Dhyan dena. Okay, how the decimal adjust accumulator operates. Okay, it looks into the previous addition cycle, and there are two things. Listen to me carefully if you have forgot DAA. Okay, if the lower nibble, okay, that is its lower result. If the lower nibble is either greater than 9, or if the auxiliary carry is set, it will add 6. It will add 6. So look into it. Yes, the auxiliary carry. What is the auxiliary carry? The intermediate carry from the lower nibble to the higher nibble. That is the auxiliary carry. So yes, here auxiliary carry is set. Either the lower nibble is greater than 9 or the auxiliary carry is set. So here lower nibble is not greater than 9, but auxiliary carry is set, and here it is going to add 6 to the lower nibble. So it becomes 0, 9. Step number 1. Okay, step by step I'll explain. Then it checks for the higher result also. Either the higher nibble that is greater than 9 or the carry flag is set. Okay. So any of them, either the higher upper nibble is greater than 9 or the carry flag is set, it is going to add 6 to the upper nibble. Okay, so the answer will be 6, 9 in that case. Answer will be the 6, 9 in that case. Yes, guys. So after the DAA is executed, the contents of the accumulator after the adjustment is going to be 6, 9. Okay, after the adjustment, it is going to be 6, 9. Chalo. Move H comma A. Okay, now contents of accumulator are moved to H. Okay, accumulator has 6, 9, that will be moved to H. Now PCHL. What is PCHL instruction? Again, a data transfer instruction. It will copy the contents of HL to the program counter directly. Okay, so PC gets what HL has. And what is HL? Dekho, pair by dekhenge. H has 6, 9. And L, look into this instruction. L contains 7, 9. Okay, so HL has 79, that 6979, that will be copied to the PC. And now my question was, from which address will the next instruction be executed? The next instruction is always executed, okay, from the address which is stored in PC, and PC has 6979. Answer is C. PC has the 6979. Answer is option number C. Okay, 6979. Answer is option number C. Done hai ji? Next question then. Okay, next question then, ready for you, dear. Yeah. 8085 microprocessor accesses two memory locations, 2001 and 2002, that contains the 8-bit numbers 98 and B1 respectively. The following program is executed. Okay, so there is the memory location. If I want to write down, okay, one thing is known as memory location, that is the address, and one thing is the contents of it. Okay, so there are two locations given. Okay, 2001 and 2002 in hexa, and their contents are respectively 98 and B1. This much is given to me. The following program is now executed. Okay, if required, this data can be used. Okay, Arya. चलिए तो देखते हैं. If required, this data can be used. So let's have a look into it. Okay, LXI H, as we already discussed, LXI load register pair immediate. Okay, the register pair H stands for HL. Register pair HL gets the data 2001. Okay, now MVI A comma 21 immediate data, move immediate data 21 to the accumulator, and accumulator gets the data 21. Okay, now INXH, INX increment register pair. INR is for increment register. INX, X always comes in the register pair instructions. So, increment register pair. So, HL will increment means increment by 1 only, okay, will be +1. +1 means agar in the pair format if I say 0001, so that actually becomes 2002. Clear hai ji? That actually becomes the 2002. Now add M. Add M. Now this is an important instruction. Listen to me. Add M. Add, of course, by default with accumulator we know. Okay, so something is going to be added with accumulator. Result is also stored back in accumulator, but what? That number which is written in the memory. Which memory location? Whose address is stored in the register pair HL. Whose address is stored in the register pair SL. Indirect addressing. Okay, that is known as the indirect addressing. Indirect addressing. Okay, so what is stored in the register pair HL? The contents. Okay, what is stored in the contents of memory? Okay, so what is there in the HL? HL has 2002. Okay, what is stored at the memory location 2002? This is the memory location which is pointed by the contents of HL. Which is pointed by the contents of HL, that is 2002. What is the contents of 2002? That is B1. That is known as the B1. Okay, so accumulator ka content here 21 plus B1, so B plus 2 CD, D 1 plus 1 is 2, so this is D2. After add M it D, it's D2. Okay. Acha ji. Now what is INXH? Again INX, as I explained you, register pair incremented by 1. So 2002 plus 1, that becomes 2003 now. Okay, now move M comma A. Okay, again M is used. The contents of accumulator will be done, will be copied to the contents of the memory location. Will be copied to the contents of memory location. Which memory location? Okay, the memory location pointed by the content of HL, but HL is modified. HL is modified 2003. So memory location is now 2003, and the contents, I'm using the brackets to specify key, I'm meaning content here. The contents of the memory location 2003 will be that of the accumulator, and after the addition, accumulator contained D2, and then HLT program halts. Okay. Yeah, Suraji, that was mentioned in the last slides. That's what I've used here. Okay, now what is the question? At the end of this program, memory location 2003. Okay, that is what I have solved. Okay, 2003. Okay, contains the number in decimal. Achha, of course, we first get the answer in hexadecimal, and the number in hexadecimal is D2. Okay, the content is D2. Okay, now D2 is actually hexadecimal. Okay, so just converting to decimal, this is position 0, position 1. D is numerically 13. 13 into hexadecimal hai, so 13 into 16 power 1 plus 2, that is equal to 19, nahi, ye kitna ho gaya? 160, 208, 210 it should be. Just check out the calculation once, it should be 210. Okay, D, B, C, D, correct. 13 into 16 plus 2. It should be 210. Okay, just check it out once, the calculation part. Okay, done hai ji. Chalo, next question. So all these are pretty expected questions in ISRO. Okay, yes, Surajit. Okay, Madhu. Yes, definitely we'll plan for computer science important topics as well. Computer science important topics, important subjects as well. Chalo, let's move ahead. Okay, let's move ahead to the next here. The contents in hexadecimal of some of the memory locations in 8085 A based system are given below. The contents of some of the memory locations, like again, some addresses are given and what is the content stored there, that is mentioned. Okay, next. The contents of the stack pointer, program counter and HL are given to you. When the following sequence of instructions are executed, okay, DAD SP and PCHL, what is the contents of SP and PC at the end of the execution will be? At the end of the execution will be, dear DAD, double addition direct. What is this command coming up? Double addition direct. Okay, so initially what is some data given to me? Okay, rather than reading, एक बार इसको लिख देते हैं. So what is given to me initially? Stack pointer, ये respectively है 2700, then program counter next 2100, and then HL is 0000. This is what is the data given to me. This is what is the data given to me. Okay ji, this is the data given to me. Chalte hain next. Okay, now let's execute this instructions. Only two instructions are there, DAD, double addition direct. One and only instruction in 8085 processor, okay, to add 16-bit numbers. One and only instruction, DAD SP, it will store, like in the 8-bit addition, accumulator is by default one of the implicit operand. Here the implicit operand is HL. Okay, by default the contents of HL will be added to that of the specified register pair, that is SP, and the result is stored back in the HL. So what is given HL? HL is 0000. Okay, HL is 0000 plus stack pointer. Stack pointer is 2700. Okay, so adding 0 not affecting the answer, so it is 2700 only. Okay, that is HL. Now PCHL, अभी हमने लिया था एक question में. The contents of HL are directly copied to the program counter. The program counter gets the HL and HL has 2700. Okay. Now question क्या बोला है? Question eventually is simple, and what is the question? Contents of SP and PC at the end of execution. SP and PC. PC gets what HL has, that is 2700, and in this SP was used but not modified. So HL is 2700, SP is also 2700. Answer is B. Answer is option number B. Answer is what? Answer number B. Done. Next question. Okay, following the segment of 8085 assembly language program, LXI SP, EFFF. यही था ना? हाँ, coming here. LXI SP, EFFF, call 3000. Okay, so call is to call a subroutine. The call instruction is used to, call a subroutine. Okay, that is stored at the address 3000, or you can label also, but here directly the address is given. So whenever the call is encountered, the program transfer will be, the program execution will be transferred to the specified memory location. Okay, now we start executing from 3000, some instructions, LXI H, something, push, PSW, SPHL, pop, PSW, return. After the completion of return execution, what is the contents of SP? What is the contents of SP? For concept, I shall explain you this complete process actually. Contents of SP तो कैसे modify होगा वो मैं बताते जाऊंगा, ठीक है? So have a look into it. Okay. नहीं, not interchange. Only one side data copy, Surajit. PCHL means contents of HL is copied to PC. That's it. It's not exchange. It's one-sided copy. Okay. It is one-sided copy. Have a look into it now. Okay. So LXI SP. So first of all, this instruction is initializing the stack pointer. LXI load register pair immediate. And that is EFFF. Okay, SP, EFFF. Okay, then call 3000. Now, dear, I told you whenever the call subroutine is encountered, the program execution is transferred to the address to the memory location specified, that is 3000. Okay, a subroutine, a subprogram is written there. Okay, a set of instructions will be executed. Okay, and then finally every subroutine contains RET. But RET के साथ कोई address तो लिखा ही नहीं है. तो where to return? Where to return? Automatically, dear, automatically it should return to the main program, na? Where to the main program? Where to the main program? So let's say after the call there is some next instruction. I will simply call it as next instruction. There will be some next instruction. Okay, so once the call is encountered, okay, once the call is encountered, I should be coming here. Okay, after these are executed, I should return back to the next instruction automatically. Right hai ki nahi? I should return back to the next instruction automatically. Now this next instruction will have an address, na? Where are these instructions? Where is the program written? That is also written in some part of the memory of the microprocessor. Okay. In some part of the memory, so there will be some address of the next instruction. Achha, so let us call those address. मान लेते हैं. Suppose, just assume, suppose this address is 2000. Address मैं यहाँ पे लिख रहा हूँ for example. Okay, LXI-SP, it's a 3-byte instruction. So next is 2003, next is 2006, and then I jump to 3000. Okay, so next instruction, because call is a 3-byte instruction, next instruction is stored at 2006. इसको time देके समझ लेंगे, but pay attention. Okay. Now the return, after the return is executed, there is no address written here, and the transfer should be automatically to 2006. So that means because I am going to come here, okay, I am going to come here, I will forget this address. Na? I was at the address 2003, but after that I suddenly come to 3000. But after the execution of this, I need to come back. So I have to store somewhere. Now, how will I remember where is the next instruction, bhai? How will I remember? For that, stack memory is used. Okay, for that, stack memory is used. Okay, and to use the stack memory, I already initialized the stack pointer. Stack pointer is pointing towards the stack memory. Okay, and what is the initial value? EFFF. Okay, let us consider this memory array. Okay, of course, assuming to be initial address 0000 and the last address is, because it's a 16-bit address, all ones means hexa mein FFFF. That is going to be the last address. In this way, I have taken to be increasing order. Okay, stack pointer is initialized with EFFF. Okay, now as soon as call instruction is encountered, okay, acha, one more point. Wherever stack pointer is pointing, that is assumed to be top of stack. This is known as top of stack, and it is assumed that some data is there at the top of stack. Whatever address, whatever data should come, that should be above it. Stack is arranged like a pile of books. Okay, so if you already have a pile of books, okay, where will you store the next book? Above it, na? Already if you have a books, अगर आपके सामने books का arrangement है, तो next book कहाँ रखोगे? Above the current book, ना? Okay, so although this is the first initialized stack pointer address, this will go blank because I'm assuming some data is there, but in the future cycle, there will be definitely some data on the top of the stack. On the top of the stack. So now what I need to store? Okay, store the instruction, store the address of the next instruction. Okay, what will the call do? इसको थोड़ा सा लिख लेते हैं, ध्यान रखना important instruction है. Okay. Store the address of the next instruction. Where? Into the stack. Okay, and then load program counter equal to 3000. Because call 3000, I told you what call means. What it should go to the address written at 3000, address written at the subroutine. Okay, from which in last questions what we learned, from which address next instruction is executed, whatever address is written in PC. So what I will do, this 3000 this 3000 I will load it to the PC. Clear everybody? Okay, so now next instruction ka address kya hai? 2006 is stored onto the stack. Okay, but stack memory is 8-bit here. Okay, so higher order is stored here, then lower order. Okay, higher order and lower order. So call is like pushing a data onto the stack. Listen to me. Call is like pushing a data onto the stack, and every push cycle will decrement the content of stack pointer by 2. Okay, it will decrement the content of stack pointer by 2. I am at EFFF. I am at the EFFF. Now I am going to come at EFFE. And then I am going to come at EFFD. Okay, first the higher order, 20 is stored. Then again stack pointer decremented by 1, 06 is stored. Okay, so what is stack pointer now? What is stack pointer now? EFFD. Okay, now next I come here. Okay, when I come here, I encounter a LXI command. Okay, LXI, we all know what it will do. Load the register pair HL with 3CF4. Okay, I have done that, 3CF4. Push PFW. Now what is push? Push is what you all know is a direct stack based instruction to push the contents of the register pair, onto the top of stack. Okay, what is the register pair coming up here? PSW. What is PSW? Program status word. And that is the combination of accumulator plus the flag register. Clear, everybody? That is the combination of accumulator plus flag register. Okay. If the contents are not specified, no problem, Ankit. They may not be used in the question. Okay. Chalo. Yes, Suraji, the same thing for you. But yeah, we know that PSW is the program status word which contains accumulator and flag register. Okay. Okay. Higher order accumulator, lower order flag register. So after push, now I am going to execute the push PSW. Okay, isko baad mein likhte hain. So what is the push cycle? Now understand. Push PSW, okay, come, it's going to be executed here. The stack pointer is again decremented because top of stack is holding some data already, na? There is a book at the top. Where will be the next book above it? Okay, so first of all, stack pointer has to decrement by 1 again, EFFC, and the higher order. In the PSW, higher order means accumulator. Whatever is the content of accumulator, which is not mentioned there, but that will be stored. Stack pointer again decremented, and it becomes EFFB, and then the contents of the lower order, that is flag register, A plus FR. So lower order FR will be stored there. So stack pointer again decrement by 2. With every push cycle, with every call cycle, stack pointer is decremented by 2. Okay. Now next SPHL. Okay. So isko yahan pe वापस लिख देते हैं. What was LXI done? LXI has done HL equal to 3CF4. Now SPHL. What is SPHL doing? Okay, HL to SP. Like PCHL, na? It is a command like PCHL, SPHL. Directly copy the contents of HL to the SP. Only one-sided copy. So SP gets what is in the HL, and what is in the HL, you upar dekh lijiye, 3CF4. So in between SP is modified, and the question is finally on SP only. Okay, so SP gets 3CF4. Okay, pop PSW. Now pop, like push is to store into the stack memory, pop is to retrieve into the stack memory. Pop is to retrieve from the stack memory. Okay, pop PSW. Okay, it will retrieve the contents of top 2 memory locations of stack into the specified register pair. That is PSW. Okay, so let's understand the pop cycle here. Pop kya hai? PSW. Pop PSW. So what happens with the pop? Okay, the contents of the memory location pointed by the stack pointer, the top of stack, that is copied to the lower order register. Right? PSW is A plus FR. It is reverse of push cycle. In the push, first you push higher order, then lower order. So when you retrieve, first lower order, then higher order. Okay, and then higher order, copy to A. Okay, acha, eventually stack pointer will again increment. Okay, eventually stack pointer will again increment, and the stack pointer will become EFFD, increment by 2. Okay, and then return. Okay, return kya karega? Return, it will copy the top 2 contents of the memory, top 2 contents of the stack memory onto the program counter. Okay, this is going to load the program counter. Okay, the top 2. Okay, lower order sabse pehle, and then higher order 20 here. Okay, this is copied, and also this is copied here. Program counter gets 2006, and as soon as the program counter gets 2006, okay, the microprocessor will now execute the next instruction. Which next instruction? That is stored at the location 2006. That means it returns back to the main program successfully. Okay, successfully. ठीक है, हाँ ठीक है, यहाँ पे तो एसपी चेंज हुआ था, सॉरी आई जस्ट मिस्ड ऑन टू दैट पॉइंट, जस्ट अ सेकंड, है ना, जस्ट अ सेकंड, pop psw, just a second, I'll erase it, I'll come back to that instruction. Yeah, okay. Yeah, the stack pointer is by the way changed, okay, and that is why the question is not asking you where the program is going to return. Okay, so what is going to happen actually, stack pointer, so there will be some memory location 3CF4, okay, there will be some memory location now randomly 3CF4, okay, 3CF4 kahin upar aayega, okay, there will be some memory location, suppose here, okay, I need to have some additional space, lot of explanation here. Yeah, suppose this is some memory location 3CF4, some random data will be stored here which I don't even know, okay, but yeah, let us suppose 3CF4 and pop will happen from here, okay, whatever is the data here, okay, suppose the data here is XXXX, okay, and 3CF4 hai ye, okay, below it will be 3CF5, okay, suppose the data at this is YY, and what will pop do? It will copy this content into the lower order is flag register, higher order is accumulator. Okay, so contents of accumulator and flag register, after it will be some garbage data which I'm not aware about, okay, and then return. Okay, now return, where it will return? Where it is going to return? थोड़ा सा मुझे space बनाना पड़ेगा. Okay, so now next instruction that is going to be at 3CF6, next will be 3CF7. Okay, there will be some more garbage data here, suppose ZZ. There will be some more garbage data here, ZZ here, it can be UU, anything, okay, and that is going to be copied to the program counter. Return be, return kya karega? It will copy the contents of the top two memory locations of the stack into the program counter. Okay, that means program execution is going to be transferred to some random, it's a badly created program, but question wise it is very much clear. Question wise it is okay. Okay, what is going to be the contents of stack pointer? So now in short, as I'm telling you, pop. Okay, whenever you pop, stack pointer increments by 2. It was at 3CF6, directly come to 3CF4 say F6. Okay, next it will come to 3CF8. Next it will come to 3CF8, and that's going to be your answer. That's going to be your answer. Okay, so what happens here? Stack pointer is incremented by 2. Stack pointer plus 2, so that becomes 3CF6, and with return also stack pointer is going to increment by 2, that is SP plus 2, and that becomes 3CF8. The answer is 3CF8. The answer is the 3CF8, option number B. Correct answer is 3CF8, and that is why they only ask the contents of stack pointer. Okay, what is the content of the memory location pointed by stack pointer? यहां पे क्या कंटेंट होगा ये हमें कुछ नहीं पता. That is why they are not asking. Just what is the content of the stack pointer register. Okay, and that is clear. 3CF8. That means, dear, always take care in such cases when they are only asking the stack pointer question. When they are only asking the stack pointer question, so whenever there is a push command or whenever there is a call command, okay, that is going to change the stack pointer, that is going to decrement the stack pointer by 2. Whenever there is a pop command or whenever there is a return command, that is going to retrieve the data from stack, and whenever we retrieve the data from stack, stack pointer is incremented by 2, that is SP plus 2. Clear? That is going to be what? That is going to be the SP plus 2. Clear? That will make it as SP plus 2. Done it? Okay. Chalo ji, next question then. Yeah. MVI L, 5D. Okay. Load the immediate data 5D to register L. Move H, A. The H gets what A has, but what is there in the A? Unknown. Unknown. Okay. Push H and pop PSW, find the contents of the flag register. It's a simple question on push and pop actually. Okay, what is the value of stack pointer? Not known to me. What is the value of the stack pointer is not known to me. No problem, no problem. Okay, but there will be some value in the stack pointer, and whenever the first push instruction comes, okay, whenever the first push instruction comes, yes, Surajit, equal number of push and pop should be there in subroutine, and no instruction like SPHL which will change the stack pointer contents. Both have to be taken care. Okay, yeah, so there will be something in a stack pointer, and we again assume by default that the top of stack is loaded, so next data should be above it. So push H, okay, the first H higher order register will come and store here. Higher order register will come and store here where SP minus 1. Then above SP minus 2 lower order register L is stored here. Okay, this is what is push cycle. Okay, now pop PSW. Now let us understand the pop. So what happens in the pop? Whatever is the current content of the stack pointer, now stack pointer is SP minus 2, that will be copied to the by PSW, as I told you, accumulator plus flag register. First the content is copied to the lower order, that is flag register. Next it is copied to the higher order, that is the accumulator. That is the accumulator. Stack pointer returns to stack pointer. What is the final contents of stack pointer? Unchanged. Okay, but what is the contents of flag register? Okay, flag register finally gets what was the content of L. This data is copied to FR and L data is known to me. What is the data at the L? वो लिख देते हैं ना यहाँ पे. The data in the L was 5D. The data in H is not known, but चाहिए भी नहीं. Okay, what is there in the flag register? That is equal to L and that is equal to 5D. This one is simple. This one is known as the simple. Okay. After the pop, this will be the final stack pointer again. This will be the final stack pointer again. It decrements by 2, again increments by 2. Again increments by 2. Hanji, done hai? Chalo, clear. Next question then. Yeah, correct. This one is simple. That is the 5D. Next. So yeah, some important and very crucial updates for all of you. So yes, guys, 3rd of December. Okay, it's around. That's just 2 days ahead. Okay, so BYJU'S exam prep brings to you the National Scholarship Test, in which if you perform, okay, based on your performance, you can get up to 90% scholarship on the GATE preparation programs. So you can take a next step towards success in GATE. Full detailed courses in English and Hindi, as well as crash courses. All different modules are available. You can take the benefit. Okay, and you can avail discounts as much as up to 90%. Again, I'm telling you, based on your performance in the scholarship test. So you can appear on this Sunday anywhere between 9 AM to 9 PM. Okay, now, what is the complete roadmap to be a topper in GATE 2025? Yes. Okay, all those started, you're starting the preparation GATE 2025. You should now only know, okay, what should be the roadmap to be a topper, so that your preparation is aligned, okay, to be in the top zone, not just to qualify, but just to be a topper of the GATE. So a free live, very interactive workshop this Wednesday, 6th of December, 7:30 PM. This Wednesday, 6th December, 7:30 PM by all your favorite Abhinav Negi sir, MTech, IIT Delhi, and more than 12 years of experience. Join on the BYJU'S exam prep app live on this Wednesday. And if you don't have the app, you can download directly from the Google Play Store, or you can download from the description of the video. There is a link in the description of the video. You can directly download using that link as well. Right? Okay, cool. Chalo. Next. So what's next? Let's move ahead to the next. Next means next question, of course. Here it is. Consider the following assembly language program. Again, good one, using some jump instruction. MVI B, 87, move A, B. So step by step, let's keep executing it. Okay. So what is the result of the execution of the above program? So let's start decoding it one by one. MVI B, 87. So register B is loaded with the immediate data 87. Okay. Next, move A, B. Accumulator gets the data from B, and that is 87. Okay. That is 87. So next, jump next. JMP. JMP is unconditional jump. Okay. What is JMP, dear? It is the unconditional jump. Jump to the address. यहाँ पे address की जगह label use किया है, because we can use the labels in this programming. Okay, jump to this address. The address has been given a name, labeled. Okay, and that is next. Okay, unconditionally. This is unconditional jump. So as soon as the jump is encountered, the program execution is going to be transferred to this address. That means it is now going to execute the XRA. It is going to execute the XRA. Okay, so XRA. What is XOR? Already we have seen that it is going to XOR the contents of the given register, which is B, with that of the accumulator by default, and the result is stored back into the accumulator. A XOR B. That is A is equal to A XOR B. Okay, so what is A? 87. 871000011. A contains 87 hexadecimal में था, and we have to XOR it with the contents of B. And what is there in the B? B also contains 87. As of now, A and B are both containing 87. 87. So 1000011. Okay, now XOR. Okay, we have to check the XOR bit by bit, and because currently they are all same. Okay, so X XOR X is 0. Now, to all the bits. Okay, it is bit by bit. Okay, but all the bits are identical to each other, so it's going to be resulting in 0. That's going to be resulting in 0. Okay. So accumulator will now become 0 after this XOR cycle. Okay, so accumulator gets the data 0 0. Now JP start. Jump on plus. What is JP? Look into this, guys. Remember, as I told you, let's keep revising here. The first one was JMP. That is known as unconditional jump. Unconditional jump. JMP and some address will be there. XXXS. This is unconditional jump. Okay, to the given address. That means the program execution is directly transferred to the given address. Okay. Now, what is next? JP. Okay, JP, some address XXXX. Rather than the address, labels are used, but that's okay, I'm telling you. Now, JP is jump on plus, conditional jump. Okay, that is jump on plus. This one is jump on plus. And how plus is checked? By the sign flag. That means, this simply means, okay, jump to the given address, whatever is the given address, if the sign flag is 0. Because plus positive number, sign flag is 0. Okay. Negative number, sign flag is 1. Sign flag is coming from? Sign flag is just the MSB of the result. Because how do you decide the sign of numbers? By the MSB. If MSB is 0, that's a positive number. If the MSB is 1, it represents a negative number. That's what digital machine coding is. Okay. So sign flag is actually 0 here. Okay. Ek one dekh lete. Sign flag is 0. After the execution, it has become 0, na? Okay, it is 0. Correct. Okay. So it is 0. So jump on plus. So, after this execution, what is the sign flag? That is 0. Sign flag means directly the MSB. Okay, the MSB 0 hai, and jump on plus. Yes, if sign flag is 0, it represents a plus number. It represents a plus number. So JP will be executed. So jump to the start. Jump to the start. JP will be executed. Now jump to the start. Okay, so I again come here. So ye kya chal raha hai? Okay, it will jump to the start, and at the start you have an unconditional jump. You have an unconditional jump, and unconditional jump means बिना सोचे समझे जो काम किया जाए ना, without thinking anything, it will jump. Okay, so it will again jump to next, and again XOR will come, but this time is going to be a difference. Okay, you might get the feeling that this may be infinite loop. No, that's what, Ankit. You may be feeling that it's going to be infinite loop, but no. This time when it comes to XOR, now, okay, it comes here. Now, this is the second round. This is the second round. Okay, that was the first round. Now, in the second round, what is going to happen? Okay, this was the first set of calculation. Now, there is a difference. Okay, let's execute this instruction once again, second time. Okay, it is A equal to A XOR B. Same instruction is there. But earlier, actually, A and B were same. Both were 8787. Both were 8787. Okay, now it is going to be accumulator which contains 00. That is going to be XORed with B, and B is unchanged. Na? B is 87. Now tell me, without solving the XOR separately, X XOR 0. X XOR 0 is always X. Na? Even if you take a single bit, X XOR 0 is just X. Okay, so 87 XOR 00. 00 means all bits are 0. Okay, so 87 will repeat. Okay, this is going to be 87. So यहाँ पे एक बार फिर से देखते हैं इसको. Okay, so now this time what I have is accumulator contains 00, B contains 87. So when I am doing the XOR, I get the 87. Okay, but 87 is 1000. I need to open it to see the sign flag. 8 is 1000 and 7 is 0111. Okay, what is this? MSB, it is 1, meaning sign flag is 1. Meaning the sign flag is 1 this time. Okay, meaning that the sign flag equal to 1. Okay, sign flag equal to 1 for minus number. Now what is the next instruction? Jump on plus. Bataiye aap. What is the next instruction? Jump on plus. Is it going to jump? It will only jump on minus. It will only jump on plus, not on minus. And now I have a minus number. Okay, now I have a minus number. Okay, so because it is minus number, JP will fail this time. Okay, JP fails. And agar JP fail hua, so next what is going to happen? It will come to this instruction. It will come to this instruction, out. Okay, now out is a command to display the contents of accumulator to an output device. Maybe suppose the LED is connected to the microprocessor. Whatever is the contents of accumulator, okay, it will be displayed on the LED, or maybe a printer is connected to the output as an output device, so that particular number will be printed, whatever it is. Okay, there is some output device connected, okay, at the address port 2. Again, address is given in the name of a label. Okay, but physically तो वो एक address होगा. Okay, so whatever is the contents of accumulator, अब इसको mention करते हैं. Contents of accumulator are sent to output device. Are sent to the output device with the given address. अभी space नहीं बचा, इतना लिख लेते. Okay, with the given address. Okay, and then the program halts. That's it. Now what happens? Okay, so output of 87. अच्छा, what is the contents of accumulator? वो contents के साथ पूछ रहे हैं. And the contents of accumulator finally is 87. Is 87 after the last XOR operation. Okay, so output of 87 is port 1. No. This address, last address was port 2. Okay, output of 87 at port 2. Correct answer is B. Finished. The correct answer is B only. Clear, everybody? The correct answer is B itself. Infinite looping to hai nahi. It was looking, some of you might get that feeling ki yaar, is it going to be going in the infinite looping? But no, actually not. Actually not. Okay. Chalo, done. So question can be n number of questions. Okay, but some important questions. I planned it as a 1 hour session, and now I have some other sessions to be going forward. So I'll stop here. I planned it to be a 1 hour session, and it's almost 1 hour. It's 5 p.m. guys. So we'll stop here. But yeah, some crucial questions to revise up. Many instructions. Okay, yes, you might have felt that actually many instructions, we have revised today. Okay, guys. So that's it. And at the same time, I will keep a simple password for today's PDF. You will get the PDF in my Telegram group. Okay, but the PDF is going to be password protected. Only those who watch the session, they get the password. That is 8085. Simple password. 8085 based on this. Okay. It depends, Ankit Kumar. In ISRO, you can expect like maybe 2 to 3. Maybe 2 to 3. It may be less also, but 2 to 3 is what approximately you can expect. Okay, ji, done hai. Okay, but not only from programming. See, today we covered programming based question because that is where students are confused. Sometimes it can be simple memory interfacing. That is more simple. Okay, or basic architecture question, and that is usually if you have read the architecture once, you can answer it there. Programming में practice चाहिए होता है students को, ठीक है? Or it could be even the T stage based question, the timing cycles and T stage. Okay, ji, that's it, guys. So that's it from my side for today. Okay, so as you know, all India Open Mega Mocks are going on the BYJU'S exam prep app. Yes, guys. So, you can participate in this. Okay, so for electronics, if you talk about, it's actually going for all branches, but this is the schedule slide for electronics. Okay, and from 25th November to the 1st December. Yes, today is 1st of December. Okay, the subject test, communication and electromagnetic. So guys, these are free mock tests. In case you have not appeared in this subject test, today is the last day, 1st December. You can appear in the electromagnetics and communication mixed subject test. And after that, from 16th December, you will have the full GATE syllabus test. Also, if you perform in these tests, okay, you get a chance to get huge discounts on the BYJU'S exam prep test series. Also, because these are open mega mocks, like free mega mocks, thousands of students are participating. If you participate, you get your performance and analysis check amongst thousands of students. So everything on the BYJU'S exam prep app, you go to the link of description of this video, you will find a link to download. You can directly download the app, okay, or also get it from Google Play Store. Keep participating. Not only the mega mocks, but there are several practice sessions happening. You keep participating on the practice quizzes and the practice sessions. Okay, you'll be seeing yourself in the leaderboard where all the GATE aspirants are participating. And as I told you in between also, the complete GATE 2025 and 26 courses are now live on the BYJU'S exam prep app in both the formats, English as well as Hindi. You can choose the batch of your choice. And if you're a GATE 24 aspirant looking for quick revision course, the crash course is also live on the BYJU'S exam prep app. Right, so that's it guys, and all these batches will contain live classes, facility of recorded lectures, study material, mock test, practice quiz, everything to get you exam ready. Okay, for any queries about the batch, you can contact 9241 333 666. Okay, that's it from my side. This is Rakesh Talreja signing off. I told you I'll share you the PDF in the Telegram with the password mentioned. Bye bye. Thank you. Stay safe and do take care of yourself.